To ensure that your world reaches the widest audience, it's a good idea to make sure that your world implements support for as many of the available platform languages as possible. That's where localization comes in, and we're going to learn all about how you can implement localization in your own worlds today. So let's begin with a brief overview of localization. And here you can see a simple diagram of how localization works. So all localized text goes through the server, and the server will translate your text into the corresponding languages. Then the localized text will go down to the clients, and the text will be displayed on the respective clients in their respective languages. There are two different types of localization. There's automatic and there are localization tables. Automatic is, as the name implies, automatic. So there's no extra work required here, and all text will be automatically machine translated, so you don't have to manually translate anything. So it's very quick to implement. However, there's less control over the text and its formatting. So because you can't really predict what kind of text will be coming in, when it's displayed on screen, it may not always be formatted the way that you'd like. Localization tables, on the other hand, are a lot more manual. So you have a deeper level of customization, and you're specifically translating all the text and you're retrieving the text in the corresponding languages. So there's stronger control over formatting because you implemented tables yourself. So you know exactly what's going on and you know exactly what's going to be displayed inside of your text. So let's review how automatic translation works. So in any of the components that you see here, chat balloons, text input, text component, and any other text-related components will usually have an allow automatic translation option. If you check this on, anytime your world is run in a different language, the text in those corresponding text fields will be automatically translated in the respective player's language. So when you publish your world, you have the option to support as many languages as you like. So this language support option here are the languages that you natively support inside of your world. So this excludes the automatic translation. So any language that is not supported, meaning it hasn't been checked in this checkbox, will be automatically translated using auto-translate. So English in this screenshot will not be translated because that's already default in our text. However, Korean, Spanish, and Chinese will be automatically translated should the player's platform language be in those languages. The source language in your world config will let the translator know what the original language in your UI is. The translator needs to know what the original language is before it translates it. So in this screenshot, the original language was Korean, and this is the machine translated version. If we then change the language to the original Korean, it will then swap back to the original Korean. Notice here in parentheses, we can see English not supported, Spanish not supported, and Chinese simplified not supported. This does not mean that we cannot translate to those languages. It just means that they're not natively supported in the world, so it will need to be automatically machine translated. So here is the original Korean text that was machine translated earlier. So you can see how easy this can be to just simply enable automatic translation and just have our machine translator do the translation for you. However, as mentioned earlier, this possibly can present an issue, as you can see here. So on the left side, we can see the original Korean, but on the right side, we can see the machine translated version does not exactly fit in the original text boxes that it was intended for. So this is the potential issue of automatic translation, where you can't really predict the amount of text and the exact translation string that gets translated and displayed in your UI. With that, let's swap to the maker and let's go into a live example of enabling automatic translation and how to test it. So here we are in Maker, and we're going to actually be utilizing a package from our MapleStory Worlds package library today. So let's open up our panels and navigate to package storage. And if we swap to the MapleStory Worlds package tab, we can see a list of all the packages that MapleStory Worlds has to offer to help speed up development. Today, we're going to be utilizing the Quest Achievement package. I've already installed this, but for you, please do so now. And once you've done so, we'll open up the core folder of the Quest Achievement package and navigate to the Quest folder and open up the README file. So inside of here, we can see a list of instructions for installation steps. So please do follow the installation steps to make sure that this package is good to go and is ready to utilize. Once you've done that, we're going to press play. And we should have access to F1 for our Quest window and F2 and F4 for a couple admin tools. So if we press F1 to open up our quest window, notice that all of our text is in Korean, and we want to auto-translate this. So let's open up the UI here. So we'll go into the sample folder and open up our UI quest. And in here, we're gonna dive all the way down to the title, description, and progress, and all of these texts. And notice that we do have, for our title, scroll down to the text component, we can see that we have the Allow Automatic Translation checkbox ticked. This will make sure that we automatically translate our text. Same thing for all of the other text in our UI. We have our Allow Automatic Translation checked on. Once we've verified that, we'll navigate to our world config and we'll check that the source language is in the language that our UI is currently in. So this is the original language that we want to be translated. So the original language in our UI currently is Korean, so we're going to check Korean as our source language. Next, we're going to publish our world, and if we click on release, we will navigate to our language section and we'll check the languages that we support. Currently, we only support Korean as that's the native language of our UI, and all of these other ones will be automatically translated using our auto translate feature. So once we've published our world by clicking on the release button, we'll navigate to the Play tab and we'll scroll to our My Worlds tab and we'll select our localization world and we'll press play. So in here, we're going to select our world language and we're going to check to make sure that it's currently at Korean. So this is our original language, and notice that all of these other ones have not supported in brackets. And again, this only means that these other languages aren't natively supported by this world and will need to be machine translated. So with the original Korean selected, let's close out this window and let's press F1 to open up our quest window. And as expected, the original Korean is displayed without being translated at all. If we now switch our world language to English, we'll get a warning that it's going to reload our world. We're going to click yes. And let's click F1 again. And notice that we now have our text machine translated into our target language. And just like that, it's that easy to get our text translated. However, there can be an issue, as mentioned, where we can't always predict the translated text and its length, and our dedicated spaces for our text may not always fit exactly the UI. Next, let's take a look at our localization tables. Localization tables, as mentioned, allow us to have manual control over the text that's localized and displayed on our text UIs. So because we are manually inputting the localized strings for each of the languages that we want to support, we know exactly what will be displayed in our UI text boxes. There's two different types of localization tables. We have our default and we have our web sync. The default will allow us to input our localization strings inside of our maker, inside of the local dataset. The web sync is our browser version, which allows us to manage our localized strings inside of the browser and sync them down into our maker. If we use the default localization table, we can see that we initially have 3 columns to work with. We have the key and the source. These two are the most important. The key will be the key that we use to pass into our localization service API to retrieve the corresponding string in our target language. The source will be the source language that we want to have. So this will be the text that our localization API will use to translate our text into the corresponding languages. If we add additional columns, we can add them in our respective languages. So we can have our English column. So under the EN column, we have our English translation. So we have our English localized strings and we have our source in Korean. So when we retrieve through our localization service API, our key_1, if our user's platform is in English, it will retrieve our EN string. If it's in Korean, it will retrieve the Korean string. With WebSync, notice that we no longer have access to edit our EN column, and instead, these strings are managed from our browser. So when we create a locale dataset, we have to define our keys and our source, and if we save that, that will be synchronized to the Manage Translation tab of our World Information page, and we will be able to edit all of our locale data inside of our browser, and we can synchronize that so our data table is populated with whatever we input into our Manage Translation tab for our supported languages. Okay, so in the example that we're going to take a look at today, we want to have 3 different localization strings. We want to have the names of our NPCs, Stan and Rena. So we have 2 keys, UI text NPC Stan and UI text NPC Rena, both with the source in English and our Korean translated string and our English translated string. Next, we have our hello text that we're going to say hi to the NPC that we interact with. So if we interact with Stan, we're going to say hello Stan. If we interact with Rena, we want to say hello Rena. And this string will also be localized into our respective languages. You can see that we have our smart formatting here, and we'll get into exactly how this works. But we can basically plug in values here as an argument into this string when we retrieve it. So let's take a look at our localization API before we hop into Maker and take a look at the exact usage of it. The localization all happens through our localization service, and we can see a couple of the methods here that we can use to pull strings from. So all the text for our localization goes through our localization service, and we're mainly going to be using the top 2 here, getText and getTextFormat here. So both of these take in a key that we pass in based on the key that we define from our data table here. So for the key parameter, we will pass in UI text NPC Stan and UI text NPC Rena. Same thing for the getTextFormat, we will use this so that we can format our string and input any arguments to plug into our key when we return it. And with that, let's head into our Maker to take a look at our example. So we are back in Maker and we have a text box up at the top and we have 2 NPCs. We have Rena and we have Stan. Currently, our localized language is in Korean. And if we go and walk to the left side, we can see we say hi to Rena. And if we walk to the right side, we can say hi to Stan. If we stop play and we change our playtest language to English and press play again, we can walk to the left. And this time we can say hi to Rena, and if we walk to the right, we can say hi to Stan. Notice that their names have changed as well, so their name tags have been updated to Rena and Stan. So let's dive into the code and see how this is working. But before we do, let's take a look at our scene and the setup. So we have 2 NPCs here. We have our Stan NPC that we just pulled from our preset list, and we searched through our NPC list inside of our NPC tab here. And if we open this up, we have all of the components that come preset in our preset list, but we've just added 2 components here. First is our tag component, which has our NPC tag, and we also have a trigger component that is just set up to be the size of our NPC. We did the exact same thing for Rena. We have added our tag component with the NPC tag, and we have added a trigger component for our Rena NPC as well. And with that, we have created a new component inside of our default player. So we've created a component and we've attached it to our player, and we have named our component our player text localization. So this is attached to our player when it spawns in, and we have access to the various properties inside of our player. So if you open up our code, our player text localization component, and we double click to open it up, we can see that we have a couple lines of code here to set up our localization. And the first thing that we've done is we've defined 2 properties, Stan and Rena of type entity, and we've set our references to be the NPC entities. So we've linked our Stan property to our NPC Stan, and we've linked our Rena property to our NPC Rena. On begin play, we first check to see if we have our Stan entity linked up. If it does, then we're going to proceed with our naming. So we're going to set the name based on our localized text. Let's open up our localization at this point and take a look at our tables. For now, ignore the very first line. We'll get into that in just a moment. But let's take a look and focus on 2, 3, and 4 as we saw in our example in our presentation. So we have our key here. We have text NPC Stan, and we have a text NPC Rena, and we also have hello. So in our source, we have our English for Stan and Rina, and we have our English localization, and we have a Korean localization. Then we have our hello string with our smart formatting, and we can say hello to our NPCs in English and in Korean. So first, we're going to call localization service and get text of our key, and this will be the localized string in our respective language. So inside of our play, if we set to Korean, then it will grab the Korean string. If we set to English, it will grab the English string. Then we're going to grab the name tag component of our Stan and Rina. So we're just going to grab this component here, and we're going to assign the name to our localized value. So this will set our NPC to the Korean name or the English name. And we're going to do the same thing for our Rina NPC. Then on trigger, we're going to check for our collision and check if our triggered entity has the NPC tag. And if it does, then we're going to grab the name tag name that we set up here, and we're going to call say hi. So inside our say hi method, we have the localized text that we are grabbing, and notice that we use get text format here. So this will allow us to plug in to this 0 here, the name of our NPC. So we're going to grab the NPC name and plug that into our 0 field here, and that will allow us to get our final localized string in our desired format. Finally, we're going to grab our localized tags. So we have a reference to our UI sprite here. If we open up our UI sprite, this is just a simple text box with a sprite GUI renderer component with this RUID setup. And we have our text component with our text value. So inside of our player text localization, we're simply going to modify the text value to our localization text to set the text of our UI. It's important to remember that all of our methods, including our trigger event, our client-side say hi method, and our onBeginPlay are all set to client or client only. So our onBeginPlay, we have to make sure that our execution space setting is on client only. And for our other say hi function, we're going to make sure that our execution space setting is set to client. And with that, that's the code for our example. I want to also highlight that we don't always have to just localize text. We can also localize sprites so that we show different images depending on our target localization. In here, we can see on the left side, we have our Korean logo of MapleStory. On the right side, we have our English logo. So imagine that we have a component with a property resource key. So that will be our key that we're going to pass into our localization service. Then in our table, we're simply going to have our key that we have resource logo. We have our source to be set to the RUID of our source. And then we can have our Korean localization and our English localization for both of those. So we have different RUIDs for different localizations. So here we have our resource logo that we are going to pull from our localization service. And then we're going to plug that in to our localization service get text. So we're going to grab our key, and that will display our image. So we're going to grab our key, and we're going to assign our sprite GUI renderer component's image RUID property to our localized image RUID. So we're effectively setting different sprites depending on our localization. And just like that, we can have different images depending on our platform. In our previous example, we utilized the default locale dataset, but if we wanted to use our web sync dataset, we can create this and we can name this web sync localization. And notice that we don't have the ability to add a column. Instead, let's just define a couple keys. Let's say key _1, and then key _2, key _3. And then for the source, we can say hi, welcome, and then goodbye. We can add a note for all of these. So if we go into our world info page by going into our hamburger menu and clicking on world info, we can navigate to our manage translation. And if we go into our world's content, we can click on the Sync Up button to make sure that our data is up to date. And we're going to pull the data that we created in our maker. Once we've done that, notice that our locale dataset populates in this page. So now we can define our various strings for the localizations that we want to support. So for English, we can just say hi, and we can say welcome, save. And then for goodbye, we can do goodbye, save. And then for our Korean localization, we can go back to our hi, and then we can save. For our welcome, we can save that. And then for our goodbye, we can save that. And then now back in our maker, if we click sync now, we can retrieve our localized text from our web. And we can still use exactly the same thing that we did for our localization, except we are synchronizing from our web instead of manually inputting it here. So both do exactly the same thing, just with different management, either directly from our data table or managed through the web. The final concept to go over in regards to localization is smart format. Smart format is very similar to the getText format that we saw earlier, where we have the ability to plug in values into our bracket syntax here. With this bracket syntax, we can plug in as many values as we want as arguments into our getText format, as long as we make sure that our syntax is proper, where the first argument has bracket 0, and the second argument has bracket 1, and so on. Smart format can do exactly the same thing, however, we can go a little bit further with our formatting, and we'll take a look at that in just a moment. So with getText format, we saw previously that we have the ability to plug in values into our string by utilizing this bracket format. So we have our bracket 0, and we only have one parameter here. But if we wanted more, then we can have bracket 1, bracket 2, and so on. And we would simply pass in additional parameters into our getText format, and that will return our final string. And in our example, we were able to plug in values into our string by using the syntax. Smart format allows us to go a step further and also be able to have different versions for the same language depending on the singular version or the plural version of our strings. So here we can see our structure for our smart format, and we're going to use our plural version. So in our smart format, we can plug in a version of our string for our singular unapple, or we can use our bracket syntax to plug in our parameter as the value here. So if we only have one apple, then our singular version would be printed. If we have more than one apple, then our plural version would be printed out here. Formatting and syntax is very, very important here. So please do check our documentation on smart format for what could happen and the various errors that can happen when you are utilizing smart format. And with that, let's go into Maker to do a simple demo of collecting apples and using smart format to output a singular or a plural version of our string. So we're again back in Maker, and in this example, notice that we have our apples, and if we collect them, because I only have one apple at the moment, we can see the string reads I have an apple. If we now start collecting more than one, we can see that our syntax changes to plug in the number of apples that we have into this string. And if I continue to collect more apples, our string updates accordingly. If I now change my language to Korean and I play again, now we are no longer utilizing our plural because in Korean we don't have plural or singular versions. So we just output the regular string with the smart format to replace the value of the input for our string. So as I collect more, we can change the value and we can see that our UI updates accordingly. Okay, so what's going on? Well, as before, we have our text sprite, we have our sprite GUI render component, and then we have the text, and this is what we're using to populate our UI. We also have apples here, and these apples don't have anything special. They just have our sprite render component, they have a transform component, but they also have a trigger component and a tag component as we did for Rina and Stan previously, except the tag for our apples will be apple. When the player enters into the trigger region of our apples, it will destroy our apples and update our text. Again, we're using the same script, and this player text localization is attached to our player here. So please do make sure that this component is attached to the player. Then opening up our script here, we can see that on handle trigger event, we have our check for the tag to make sure that the tag contains the apple tag. If it does, we're going to call gain apple, and that's going to increase our apple count. So if you have a property up here to keep track of the number of apples that we currently have, and we're going to increase the number of apples by 1 and then destroy this apple. Once we've done that, we're going to update our UI with our apple count. So since we've updated our apple count, it will have 1 apple. So we're going to use getTextFormat to return the string. And if you go into our localization, we can see our source has our plural syntax. So our English has this smart format string where we have 0 and we have our plural. And then for our singular version, an apple, and our plural version for multiple apples. So for our English localization, we have this smart format. But for our Korean version, we don't have the smart format. We just have a single parameter that we're going to plug in our value for. So with our getTextFormat, we're going to retrieve our final localized string, and we're going to assign that text to our localized text. And that's it. We do exactly the same thing as we did for our MPC. And now we have our smart format syntax to use singular or plural versions of our string. In the case of Korean, we don't want to use smart format. So we are simply going to use our bracket syntax to simply plug in the value, whether it's singular or plural. Today, we've gone over localizing your worlds in different languages to make sure your world is playable for players even if they don't speak the languages you do. Now go add localization to your own worlds. Happy creating!